Hi everyone, in today's class we'll see the concept of D flip-flops. Guys, here D means dilemma, so totally I can call it as delay flip-flop. The reason why they are calling it as delay flip-flop means whatever the input that you are going to give, the same input you are going to get at the output side, but it may take some time. Means we can say that it may produce the same output after some time. That's why they are calling it as delay flip-flop. Okay, so basically this delay flip-flop you can able to get it with the help of T flip-flop. So in the previous video we have seen how you will get the T flip-flop, right? So this is the circuit diagrams for the flip-flops of T type. So basically, any kind of flip-flop you can able to implement with the help of either NOR gates or through NAND gates, right? So we constructed the synchronous JK flip-flops using SR flip-flops, and from synchronous JK flip-flops we construct the T flip-flops. Now from T flip-flops can we able to construct the D flip-flops, right? So D flip-flop is same as like T flip-flop only. The difference is in terms of the way that your input is passing, right? So here instead of passing the direct data, they are going to make it complement. So this is what we can call now as D flip-flop. So here I made it as D. Technically I am writing it as D, right? Now this red color, this entire circuit diagram, I can call it as D flip-flop using NOR gate. Similarly, how can we convert the D flip-flop using NAND gate from T flip-flop? So basically you can simply convert, make this input changes, right? When you are passing the data, it should be toggled. So this is what I can call it as D technically. So there is no problem, you can call it with anything, but as part of the circuit diagram representation I have mentioned like this. So this is what I can call it as D flip-flop, guys. Basically, so representing this thing every time is going to be a complex thing. That's the reason you can able to represent it in simple notation. We can call it as entire structure notation that will look like this, right? So basically you are expecting the outputs as, or if it is one is Qn, another one is Qn bar, and here the inputs might be J and K, right? Now basically you are going to pass D as input, the same D you are going to pass it to J, but for K you are going to make it toggle. This is what also I can call it as a schematic diagram for the D flip-flop, right? Okay, fine. So once we drawn the circuit diagram, can we able to define its characteristic table? Yes, right? So characteristic table means how your circuit is behaving for the inputs of D, and for the present state of Qn. So here I have taken one input D and the present state is Qn. Then what might be the Qn plus 1, I am going to write directly, guys. So if you want, you can just like analyze it so that you can get this characteristic table, right? So earlier videos we have gone through how we can able to derive the characteristic table for JK flip-flop as well as SR flip-flop. You can go through that so that you can get idea how to debug this respective circuits, right? So here I am going to have two variables. One is 0 0, 0 1, 1 0, 1 1, 1 1. How your Qn plus 1 is going to behave, right? So Qn plus 1 is going to behave as it is like input, right? Meaning that if I am going to give the input, the same input you are going to produce the output after some time, right? So which means that irrespective of Qn, you are going to get here as 0 0, 0 0. I can say that it's a kind of reset mode only. Right? Yes. Similarly, here what might be the Qn plus 1 values? They are 1 1. They are 1 1, right? Yes. So you can observe here 0 0 is there, the next state will be 0 0. Here 1 1 is there, the next state will be 1 1. So this is what the meaning of D flip flop, right? So can we able to derive the characteristic equation for this? Yes, right? So characteristic equation basically can go with K maps. So here, as part of the simple way of writing, because I am going to have only two variables, I no need to simplify also. I can directly write this. So Q1 plus 1 I can be written as dQn bar or it can be dQn. It can be dQn. Guys, can I write it as, if I take the common d, you can get dQn bar Qn, you can get as d, right? This is 1. So Qn plus 1 I can be written as Q only. Written as Q1, right? If you are getting confusing, try to do it with the K maps, right? As we are going to have two variables, you can just simply take dQn 0 1 0 1, and for what values we are getting the 1, for 1 0 you are getting the 1, for 1 1 you are getting the 1, right? So you can able to form the maximum subcube of size 2. So this is what I can call it as D, right? Which means from this one you can draw the circuit diagram. Yes, we can draw the circuit diagram easily, right? Which is like nothing, right? So as usual, like D as the input, whatever the D you are passing, the same D you are going to get at the output side. Okay, fine. Now let's do one more table called function table. So function table is going to define the output, the next state in terms of its present state, right? So basically if you are going to have D as the input, what might be the Q1 plus 1 in terms of in its input, right? If I am going to use 0, its Q1 plus 1 be 0. If I am going to 1, it is going to be 1. It's going to be 1, right? So there is no use of Qn. Similarly, can we draw the excitation table for this? Yes. Excitation table means writing the inputs with the help of its outputs. Right? So basically, one is Qn, another one is Qn plus 1 are the present states and the next states for the respective table. But what might be its input when Q1 and Q1 plus 1 are given, right? So that is what they are asking. So you can able to observe, right? If I am going to have 0 0, your D is going to be 0. If I am going to have 0 1, your D is going to be 1. If I am going to have 1 0, your D is going to be 0. If I am going to have 1 1, your D is going to be 1. So this is the respective excitation table. Similarly, we can able to draw its state diagram, right? Guys, for all kind of flip-flops, we are trying to draw the state diagrams. Am I right? Yes. So similarly, here also we can draw the state diagram. So if you are going to giving the names as one is 0, another one is 1 as the two states, if I am present at this state, basically I can call it as present state, and Q1 plus 1 is the next state. If I am present at the 0th state, I can call it as present state. If I am present at the 0th as the present state, if you got the input 0, where you are moving? You are moving to 0 only. If I am present at the present state as 1, if I got the input 0, then I am going to move it to 0. If I am present at the present state as 1, and if I got the input 0, I am moving to 0th state. Similarly, if I am at the present state as 0, if I got the input 1, I am moving to first state. Similarly, if I am present at the 1 state and if I got the input 1, I am going to move to the same state. So this is the respective state diagram for the D flip-flop. Means with the help of the state diagram also, we can able to represent the entire circuit diagram for the D flip-flop. Right? These are the different ways you can able to represent the circuit diagram of the D flip flop. Right? I hope you understood clearly. Thank you.